Example 61. 4x minus 6 equals 2x plus 10. Now it says here, notice here, that the x is on both the left and the right sides of the equation. This can make it difficult to decide which side to work with. We fix this by moving one of the terms with x to the other side, much like we moved a constant term. A constant term just means a number, something we know. It doesn't matter which term gets moved, 4x or 2x. However, it would be the author's suggestion to move the smaller term to avoid negative coefficients. Listen, like, to avoid negative coefficients, does anybody really think we're going to understand that right now? Listen, don't worry about that. For this reason, we begin the problem by clearing the positive 2 by subtracting negative 2x from both sides. So let's just solve the problem instead of like worrying about negative coefficients. Example 61, 4x minus 6 equals 2x plus 10. All right. So what do we got here? What they're saying here is that you want to move the things you know. We know what minus 6 is. I know what 10 is. I'm not sure what 2x is, and I'm not sure what 4x is, because what's in x, right? We don't know yet. We have to solve for x. We don't know what x and x. So what they're saying is that everything should go on one side or everything should go the other. Now, when they're saying to avoid negative coefficients, a coefficient is really this number right here next to the x. Don't worry about that. Simply what they're saying is that the number with the x, it would be nice if the result, when you've moved it to one side, would be a positive number. So if you move, like, they like to move the x's first. I don't like that. I like to move the things I know first, right? So the first thing I'm going to do is move this negative 6 to this side. So 4x minus 6 plus 6, right? Because I want to get rid of, actually I'm putting this in brackets, but I shouldn't. Negative 6 plus 6 equals 2x plus 10 plus 6, right? I did my plus 6 here. I did my plus 6 here. I want to get rid of this negative x. So let's rewrite this. 4x minus 6 plus 6 equals 0 equals 2x plus 10 plus 6 equals plus 16. We're at 16 now. We got this, right? Now, another thing I want to talk about. If there isn't, like, a square here and a 2 here, you can add and subtract x's. So what do I mean by that? Well, I have a 2x here and I have a 4x here. If I subtract 2x here and I subtract 2x here, what I'll do is I'll get rid of this, right? Because 2x minus 2x equals 0. And 4x minus 2x equals 2x. And I bring this down, 16. So 2x equals 16. We got that. Now, I'm going to talk about this a little bit more after. Follow me, though. Just believe me, you can do that. If you have a something x and something else x, you can add and subtract those like you would a normal number. Because although they are unknowns, they are what we call like terms. They're the same type of unknowns. And you can add and subtract equal unknowns. I'll prove it after you. So once again, we want that x. When we're stuck with 2x, what do we do? Well, 2x is really 2 times x. And anytime I want to get rid of something, like to get back to what I had, let's say I just had x. This is what I want. How would I get 2x? Well, I'll multiply by 2x. How would I get rid of that 2 and that 2x? I would divide by 2. And I come back to the same thing. So I'm dividing both sides by 2. And that equals x equals 8. I wanted to take a look at this x's combining like terms. So let's just do, for an example, 2x plus 3x plus 4x plus 5x plus 6x. All right, equals 19x. Now we're not going to solve for x here. I want to show you what we can do with like terms. Since before I've been telling you what we know and what we don't know. When what we don't know is all the same, we can say they're like terms. Let's put a 1 here, plus 1. This is not a like term to all these others. This is different. We know what 1 is, but it is different. This is what I'm talking about. All right, let me just make sure that we're good here. All right, so let's take a look at this. 2x plus 3x equals 5x. They are like terms, we can combine them, and we get plus 4x plus 5x plus 6x equals 19x. And we add the 1 here. 5x plus 5x equals 10. 4x plus 6x equals 10. Right, so that's 10x here plus 10x there equals 19x plus 1 here at the end. You notice how we're combining the like terms. We're just taking all the x's and putting them together. That's all I'm doing. So now I have 10x plus 10x equals 20x equals 19x. Then I have a 1 here. Now the like terms here are 20x and 19x. Those are the same. We don't know what x is, but we don't know equally what both numbers are. And we have a 1 here, which we know. So that's one type of term. So these are like terms. And since there's only one of them, this is a term. Like terms we don't know. A term we know. How do we solve for this? How do we solve for this? Well, I can take 19x on this side and subtract 19x to get 0. But I'd have to do it on this side also. So let's do it. 1, 20x minus 19x equals x. So that would be plus x equals 0. So this becomes 1x, or x, means the same thing, and 19x minus x equals 0. 19x minus 19x equals 0. So we got to get rid of this 1 here. We got to put it on the other side because we want to solve for x. So what do we do? Minus 1 here, and minus 1 here, and we cross this out, and we get x equals minus 1. Example number 62. All right, they're showing the next example illustrates the same process with negative coefficients. Notice the first and smaller term with the variable is moved to one side, this time by adding because the coefficient is negative. So what are they saying here? Okay. Okay, let's write this down. 63, killer problem. Minus 3x plus 9 equals 6x minus 27. So what they're saying here is that whenever possible, get rid of the negative. You don't have to. It's just going to make your life easier. Let's get rid of the negative x here. So what are the like terms, first of all? This here's got an x at the end of it. This here's got an x at the end of it. This here doesn't. This here doesn't. These are like terms. These are like terms. Let's combine them. And what they're saying to do here is get rid of the minus 3x by adding 3x on both sides. Let's do that. This cancels out. Get 9 equals 6x plus 3x equals 9x minus 27. And then, of course, let's look at what we have left. This is a term. This is another type of term. These are like terms. These are both numbers without any x at the end of it. This is a term, a number with x. We have to combine these two. And we have to combine them in a way which will allow us to solve for x. So we're going to move this junk right over here. And we will do this by adding 27 to both sides because we have minus 27, add 27. Here we have to add 27. It's canceled out. This is 0. So we get 9x. And we get 9 plus 27 equals 36. Let's take a look at this. 9x is really 9 times x, right? How do we or 9 times x, right? Two numbers in brackets like that, or that's a multiplication. 9 times x, how do we want x? So if we multiplied by 9 to get 9x, we divide by 9 in order to get rid of that 9x, the 9 in the 9x. So we divide by 9 both sides. That equals 4. 36 divided by 9 equals 4. At 9 divided by 9 here, we erase that, we're left with x. X equals 4. That's our solution. Linear equations can become particularly interesting when two processes are combined. In the following problems, we have the parentheses and the variable on both sides. Notice in each of the examples, we distribute and combine like terms, then move the variable to one side of the equation. All right, let's take a look at this problem. This problem does look like a pain in the rear. Check this out. This is like, yuck. This is a mess. It's a mess. 64, 2, x minus 5 plus 3x equals x plus 18. So the first thing we want to do is the parentheses. Can we solve what's inside the parentheses? We can't, right? We got an x here and we got a regular number here. This is a variable. This is a constant, right? Those are the terms that they use. There's just a number we don't know with a number we know. We cannot subtract or add those things. We can only multiply and sometimes divide, or most of the times divide, or almost always divide. So what we do is use the distributive property. We take this 2 here and we multiply it by whatever's here. And we take the 2 here and we multiply by whatever's here. Notice I'm including the minus sign here. So that's 2x, right? 2 times x equals 2x. 2 times negative 5 equals negative 10. Plus 3x equals x plus 18. Now we want to get all the x's together and all the non-x's together. Or another way of saying it is we want all the variables together and all the constants together. Variable because it could change, this number, the value of it could change depending on what I put into that x. And this negative 10 is going to stay negative 10 no matter what I do. No matter what I do to that negative 10, that's a negative 10. It's not changing. Neither is this 18. These are the like terms. These are the like terms. We have two sets of like terms. So we can add and subtract like terms. 2x plus 3x equals 5x. We have to bring this guy down, minus 10. You see how I did that? I did this plus this. Puff, 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 puff. That turns into negative. And not negative, it turns into 5x. The minus 10, I just bring it down. There are no other like terms on the left-hand side. Now let's look on the right-hand side. I have x plus 18. I can't do anything with that. Let's just write it down. Can't do anything with that. Nothing. So now we have to put the x's on one side and the numbers on the other, because we're trying to figure out what x means, what x is equal to. What do we put inside x to make this equation work? So we subtract an x here and we subtract an x there. And also this minus 10's got to go because we got to go put it on that side, right? We got to put it right here on this side. So we would add 10 here and add 10 there. 5x minus x equals 4x. Minus 10 plus 10 equals 0. X minus x equals 0. 18 plus 10 equals 28. We're getting somewhere. We are getting somewhere. 4 times x, that's what this represents. If I want to get x, I got to get rid of that 4. How did it get there in the first place? I multiplied by 4. So therefore, I divide by 4 to get rid of it. And I have to do it to both sides. And I get x equals 28 divided by 4 equals 7.